Good morning, students. Now it is HS second year mathematics class. We are doing calculus and continuity and differentiability. That chapter we are doing. At present we are doing the continuity. We have done up to question number 28 of this exercise 5.1. So now we will continue this exercise and I hope today we will finish this one. So now question number 29, it is like that the function is defined by fx equal to kx plus 1 if x less than equal to 5, thrice x minus 5 if x greater than 5. We have to find the value of k given it is what? That it is continuous, fx is continuous at x equal to 5. So let's do this sum. Question number 29. Fx here it is given as kx plus 1 when x less than equal to 5, and it is thrice x minus 5 when x greater than 5. This is our question, and given it is what? This is continuous given fx is continuous at x equal to 5. It is given. What is our target? To find the value of k. So of course our left hand limit, that is limit fx x tends to 5 minus is equal to limit fx x tends to 5 plus is equal to f5. We know LHL is equal to RHL is equal to FL. So that formula we have used. Now, when x little bit less than 5, 5 minus means little less than 5. So of course, we will follow fx equal to this one, kx plus 1. Here also, x tends to 5 plus means little greater than 5. Of course, we will write fx as thrice x minus 5. That type of things we have used already. Now f5 equal to 5, it is this. So of course we will write k into 5 plus 1. Now if we draw the limit, then x will be replaced by 5. Here if we also replace this, if we all remove this limit, then x we have to replace by 5. Now this is the thing we are getting where LHL, RHL is equal to FA can be expressed this one. Now this term repeated twice, no need to write 2 times because equal to sign is there. Now 5k is equal to 3 5 are 15, 15 minus 5 is what? 10. 10, 1 goes this side, it is what? 9. So what is k here? It is 9 by 5. So student, you see that this is the technique of doing the question number 29. So almost same type. This type 28, 29 these are same. Now 30. 30 is also like that. Find the values of a and b such that the function defined fx equal to 5 if x less than equal to 2, ax plus b where x greater than 2 less than 10 and fx is 21 if x greater than equal to 10 is a continuous function. So that is we have to do. So it is question number 30. Here fx is according to them it is given 3 values: 5 when x less than equal to 2, ax plus b if x is greater than 2 less than 10, and 21 if x greater than equal to 10. Here students, you see that all the real numbers they have given. Less than equal to 2, all the real numbers less than 2 they have considered, then greater than 2 less than 10, then greater than equal to 10, that is more than 10. So you find total real number is given here and it is divided in three parts. First part, second part, third part. They have not said it is continuous at some point. They say function is continuous. That means now we have to use our mind and we have to use that technique that here 2 is the breaking point. So continuous functions that should be continuous at 2, and not only this, it should be continuous at x equal to 10 also. So for x equal to 2, here LHL RHL is equal to f2, so we will write limit fx x tends to 2 minus limit fx x tends to 2 plus is equal to f2. So this is our rule of being it is a continuous at 2. Why we have selected 2 only? Because 2 can give one value of one set of value of a and b. 10 also will give another set of values of this a and b. So we will use that technique, limit x tends to 2. If it is less than 2, its value is 5. If it is x tends to 2 plus means it is greater than 2. If it is greater than 2, then value is ax plus b. What about f2? Equal to 2, then it is 5. Now you see that 5, if you draw the limit, here if you draw the limit, it is twice a plus b is equal to 5. So what we get? Twice a plus b is equal to 5. This is our first equation. We have to find the values of a and b. That's why we need another equation to solve this a and b. Now for x equal to 10, if we consider this one, here again limit fx x tends to 10 minus limit fx x tends to 10 plus is equal to f10. This is also we are using same technique, LHL is equal to RHL is equal to FF with this formula. X tends to 10 minus means a little bit less than 10. Less than 10 it is what? This one you will consider, and here it is ax plus b. 10 plus means greater than 10, it is what? 21. So it is, I am directly writing it is 21. What about x greater than equal to? Then also it is 21. So both the cases it is 21. So we remove one thing. So what we get if you draw the limit? 10a plus b is equal to 21. Our first equation is this. So from 1, twice a plus b is equal to 5. I have written, we got this relation between a and b, and we have written this one just below this. Then if we deduct b cancel, 10a minus 2a is 8a, and it is what? 16. 21 minus 5 is 16. So what is a? A is 16 by 8, so a is 2. So we get value of a as 2. Now if we use equation 1 from 1, b is what? 5 minus twice a. 5 minus 2 into a is 2. So 5 minus 4, that is 1. So what we get? B as 1. So student, you see that same sum, type of sum, but here it is little bit critical type. That is, you cannot, earlier they have said it is continuous at some point, here not said, first thing. Second thing, that here you have to find the values of a and b, not relation between a and b. If they ask relation between a and b, definitely you will give this one, but this is the not said. So that's why we will use our mind. After applying mind, we will use that x equal to 2, LHL is equal to RHL is equal to FF. This will give one set of values of a and b, one relation between a and b, one equation between a and b, and At breaking point 10 also we will get another equation between A and B. Then after solving this one two, we will get the a value of A and B. So with that we end our question number 30. Now question number 31. 31 said, show that the function defined by fx equal to cos x square is a continuous function. Fx equal to, they have given cos x square. Before doing this one, we will use one theorem. That theorem is, if f and g are two functions, continuous function, then f of g is also continuous. F of g, that is f composition of function f and g. That is, two functions, if they are continuous, then their composition is also continuous. That theorem we will use here. Now we will take, let gx equal to x square and hx equal to cos x. That is our assumption. We have taken two functions. Two functions we have selected. One is gx, another is hx. Gx we have written as x square and hx we have written as cos x. Now see, if we write HOGX, this will give what? HGX, according to the definition of composite function of chapter 1. Chapter 1 relation function that we have done this one, so that we are using here. Then HGX, here it is x square. I have written the values of gx. Now see, hx, then cos x. If I write y, then we have to put here y. Whatever we will put here, that we have to put this place. So then we have to write it cos x square. So what we get, that is HOGX is our fx. Now here gx is gx and hx are continuous functions. Why continuous function? Gx is what? X square. So x square means it is algebraic function. So it is continuous. Every algebraic function is a continuous function. Or every polynomial, you can say it is all algebra, not every polynomial function is continuous. So that x square is given, so it is a polynomial. So of course it is continuous. Cos x, trigonometrical ratio, sin x, cos x, this type of functions are continuous. So gx, hx both are continuous. Therefore by theorem, it is one theorem is there that by theorem fx, what is fx? Cos x square. Cos x square means HOGX is continuous. So you see that I have used help of another theorem that two functions, if they are continuous, then their composition is also continuous. With that I have proved this question number 31. So we are using here composite function. So that you have to remember that. That's why I am doing here every sum of this question only to what? So that you can get a good knowledge of this exercise. Now question number 32. Still your view, you can say that if you are comfortable in giving all the sum, then you can say also in my mobile number, or when I will take in the Google Meet, then also you can say this, yes, this technique is, we are gainer in this technique of presenting my answer. show that the function defined by fx equal to modulus cos x is a continuous function. So here again they have given composite function. So let's see how it is. Fx is modulus cos x. Modulus cos x. Now we will try to manage this sum in composition of function, composition of two continuous function. How we can use? Let gx is equal to cos x and hx equal to modulus x. Then you have to take this one by applying your mind. You have to think that now HOGX, is it our fx or not? Here I have used this technique. I have think that yes, if I choose this way, then we will get. এখানে এইভাবে যে ধরা gx is equal to cos x, hx equal to modulus x, এটা তোমার মাথাতে আসতে হবে, নিজে থেকে এটা গেইন করতে লাগবে যে আমি এটা যদি ধরি তাহলে কি পাবো fx equal to this. This is your own talent will give these things. Now HOGX, it is what here you see that HGX. Gx is here cos x. I have replaced gx by what? Cos x. This is by definition. From that I have written this one. Now see, whatever it may be, it is the modulus one. If it is cos x is there in place of x, then of course you will write as modulus cos x. Now what is this? Modulus cos x to fx. So we get what? HOGX is our fx. Gx and hx both are continuous functions. Here gx and hx both are continuous functions. Now see how gx is continuous function. Every trigonometrical, that is sin x, cos x, these are continuous, so that's why it is continuous. Gx is continuous. Modulus function, it is also continuous, but one thing you have to remember, modulus function is continuous but not differentiable. এটা continuous হয় কিন্তু এটা differentiate করা মানে ডেরিভেটিভ বের করা যাবে না কাকে? মডুলাসকে. So both are continuous. So by theorem, it is that theorem we are using again, that composition of these two functions, that is fx, is continuous. But already we have said that two functions, if they are continuous, then their composition of two functions is also continuous. So that will give what one? That formula we are using again and again. Now we are going to start next question. Next question is question number 33. 33 I want to give as homework, so that's why I expect you should use this one. It is I will give as homework. Now 34 we will do. 34 they have given fx equal to modulus x minus modulus x plus 1. What is 32? 34. 34 is find all the point of discontinuity of f defined by fx equal to modulus x minus modulus x plus 1. So here it is what? Fx is our difference of two modulus function. We have to find the point of discontinuity. কোন জায়গায় এটা ডিসকন্টিনিউয়াস হয়ে আছে সেটা আমাদের বের করতে হবে. Now we will use that formula. FOG we will not use. Here we use f minus g is continuous. When continuous? If f and g both are continuous. So we will use that one. So how to use this one? So of course we will choose two function. Let gx equal to modulus x and hx is what? Modulus x plus 1. That is the thing, that to choose this type of functions. So I have chosen gx as one function, hx as another function. Here gx and hx both are continuous function. Of course, why continuous? Every modulus function is continuous. And what I said, but reverse is but continuous but not differentiable. Sometimes we said now that to find one theorem which is continuous but not differentiable. This is the example that modulus function are continuous but not differentiable. Not able to do the derivative, that is called differentiable. Here this is a continuous, that is also continuous. Why? Because modulus function. Modulus function, we know the graph is what? This one, modulus of x, its graph will be like that. You see, it is so no break is there. কোনো break নেই, তো এটা তো continuous হবে। তো for this one also, it is the graph of what? That gx, that is y is equal to modulus x. এখানে কোনো break নেই, এদিক থেকে এদিকে, এই দুই দিকে endless আছে। And here hx equal to modulus x plus 1, if you want to draw the graph, then you will find at the point this, it will go like that one. So these are the two. So here also it is little up, x-axis, y-axis, and it is what? 1, 0, 1, 2, like that, at the point this one. So you find, though it is not a same straight line, but here it is, they are what? They are not what? Discontinuous at any point. একটা কার্ভ থাকতে পারে, তার মানে কি এই কর্নার জায়গাটা ব্রেক না, এক দুইটা স্ট্রেট লাইন এভাবে গেছে, তার মানে কি এটা তো ব্রেক না, এটা they are joined at some point, so they are continuous. So maybe yes, these are two rays, you can say, not straight line ray, joined at this point, so of course it is what? Continuous. There also it is continuous, so that's why gx and hx both are continuous. So you cannot say that they are discontinuous function. Every modulus function is continuous function. Or if you find that you can draw the picture for better explanation, and if you find that it is what mark is given more, then you can take the LHL and LHL, RHL of this one, and you can show here also, you can show the LHL, RHL, and can explain your answer. That is one. Marks will give you the direction to how much you will answer. So there, if it is mark is less, suppose 1 or 2 mark given, then you use this technique. Okay. And fx is what? Gx minus hx. Yes, if we deduct gx, hx from gx, that is modulus x minus modulus x plus 1. This will give our fx. So fx can be written as gx minus hx. Then by theorem, yes, one theorem is there. What is the theorem? That by theorem I will write here, if gx and hx are continuous, then gx minus hx, that is the difference of two continuous function, is continuous. If you want, you can write in earlier sum also, you can write the total formula, that will give a better explanation. So you can write that yes, if gx is a continuous function, hx is a continuous function, then gx minus hx is continuous. Sometimes we will find their product fx into gx, gx into hx. Sometimes you will find earlier FOG, you will write that if gx and hx are continuous, then GOHX is also continuous. So this way you will present your answer. You can write these things, it will give a better explanation. So that we have written, therefore fx is continuous. But they have not asked to say that function is continuous. We are able to calculate that yes, our fx is continuous function. That does not mean that we match. They say find the point of discontinuity. So as it is continuous function, so how many point of discontinuity? There is actually no point of discontinuity. Therefore, there does not exist any point of discontinuous in our fx. So fx does not have any point of discontinuous at that point. So that is our question number 34. So students, I have done all the sum of this exercise. Hope that definitely you get some ideas of this one, and little bit I will just start the theorem of exercise for required for exercise 5.1. We will discuss what is derivative. Now we have done only the limit and continuity, but we have not done the derivative. What is differentiation? What is derivative? That let's little bit we will explain, and then we will move towards our exercise 5.2. Derivative symbol is what? Dy dx. We tell that differentiation of y with respect to x. This is what in commonly we say the rate of change of y with respect to x. That is, here change of dependent variable with respect to the very small change of independent variable is called our dy dx or differentiation. In geometrical presentation, suppose y is equal to fx is this. At that point, suppose p, if we want to calculate dy dx, that actually means that if we draw a tangent at that point p, what I have said, if we want to find the dy dx at the point p, then how to calculate geometrically dy dx? It will be, if we draw a tangent at that point p, it will make tangent, we know tangent is a straight line which touches the curve at a single point. That makes an angle, suppose theta, with the positive direction of x-axis. Then slope of this tangent, slope of tangent means tan theta. This is what geometrical meaning of dy dx. So that we have, we know these things, we have knowledge of this one from class 11. Class 11 we have learned all these things, and we know that what is general meaning of derivative, what is geometrical meaning. General meaning is what? Rate of change of y with respect to x. Geometrical meaning is what? Slope of tangent. Now we have to will write all the formula for derivative. And another thing, first principle also you have to mention. If fx is a function, then f dash x is limit h tends to 0, fx plus h minus fx by h. This is called first principle. And with that first principle, we deduce so many formulae. So we will write all the formulae. First one is ddx of x to the power n is n x to the power n minus 1. Second is what? ddx of e to the power x is e to the power x. Then ddx of a to the power x is a to the power x log a base e. Then ddx of sin x is what? Cos x. Then ddx of that formula you have to remember it again. Cos x is minus sin x. ddx of tan x is what? Sec square x. ddx of cot x is equal to minus cos x square x. Then ddx of sec x is what? Sec x tan x. ddx of cosec x is equal to minus cot x cosec x. Then I have missed one. ddx of log x is equal to modulus x. No, only 1 by x. ddx of log x is 1 by x. ddx of sin inverse x is 1 by root over 1 minus x square. ddx of cos inverse x is equal to minus 1 root over 1 minus x square. ddx of tan inverse x is 1 by 1 plus x square. ddx of cot inverse x will be what? Minus 1 by 1 plus x square. Now I will manage somehow to only 15. ddx of sec inverse x is 1 by x root over x square minus 1, and ddx of cosec inverse x is equal to minus 1 by x root over x square minus 1. So this formula at present you have to remember that you have already done in class 11. So that you will remember. After that we will do chapter that is next exercise 5.2. Definitely we will do this. With that we will end our today's class.